For this lesson, we're going to talk about transformers and turbines. Our learning target is I can describe how electrical energy is generated and transmitted throughout the US. Our essential questions are, what does a transformer do? Why do we need transformers? How does a transformer work? And how does a turbine play a role in power generation? So first, let's talk about transformers. Electricity produced at power plants is transmitted through power lines at very high voltages. This is why power lines are so very dangerous. You never want to touch them because there's such high voltage moving through them that it can be lethal. In order for the voltage needed, the electricity has to be changed or transformed. This is where a transformer comes in. It is a device that increases or decreases the voltage and current of two linked alternating current circuits. A transformer changes voltage and current by inducing a changing magnetic field in one coil, which then induces an alternating current in a nearby coil with a different number of turns or loops. We're going to explain this a little bit more in depth in the coming slides, but that is a general explanation of how a transformer works. So why do we need transformers? Why are they important? Well, as current runs through power lines and wires, it heats up the wires. Moving electrons are going to do that. And so, over a long distance, this heat results in massive losses of power. Anytime the energy that is being produced produces heat, that is energy that has been lost. So, if we use a lower current and a higher voltage, you reduce the amount of heat lost in this transfer. So, this is why we need transformers. However, you can only transform current and voltage with alternating current, which is why we use it, so that we can transfer electricity over far distances in the US. So how do transformers work? We have a diagram here of two transformers. The first one here is called a step-up transformer, and the second one here is called a step-down transformer. I would recommend drawing a diagram of these in your notes. So step-up transformer, step-down transformer. Each transformer has two sets of coils wrapped around an iron ring. So we have our iron ring, our iron core here, and we have a primary coil and a secondary coil on both of these. Now, the alternating current in the primary coil induces a changing magnetic field in the iron core. So we have an alternating current move through this primary field. Now, because that alternating current is moving, it creates a magnetic field. That's what we talked about when we talked about the idea of like an electromagnet. So this core then induces a alternating current in the secondary coil. So we have this coil right here produces a magnetic field through electromagnetism, and then this core produces an alternating current with electromagnetic induction into the secondary coil. So both of those principles are used here. So if in your coil you have more loops on the primary than secondary coil, which is what we have as an example right here, more loops on the primary coil than the secondary coil, that is going to be what's called a step-down transformer. You decrease the voltage and increase the current. Now, when you think about the idea of step down, that down refers to the voltage. So make sure you remember when we're talking about step-down transformer, you know that the down refers to the voltage. Also, you need to know that the primary coil has more turns than the secondary coil in a step-down transformer. If you have more loops on the secondary coil than the primary coil, that is a step-up transformer in which the voltage will be increased and the current will be decreased. So if you think back to electricity when we were talking about electric power, you'll remember that power equals current times voltage. And so what this is doing, what we're doing here is we're actually maintaining the same electric power in our, in this circuit, but we are changing the voltage and the current. And so the power is remaining the same. We're just changing. So in this case, we see that the voltage goes from 110 to 120 volts. If we had, if we looked at the current, because the voltage doubled here, the current would be cut in half. And the power would remain the same. So, for example, here, if we had 110 volts and 10 amps of current, that would mean we have an overall power of 1,100 watts. Over here, this would have 220 volts, and we would have 5 amps, and we would still have 1,100 watts. You don't need to know the math, but I did just kind of want to explain that. So, let's talk about turbines. In order to create the power that goes to the transformer, we need to use a generator in order to create that power. So, in order to turn the generator to create the electricity, we need mechanical energy. So, we use turbines to turn the generator. The turbines provide the mechanical energy, and then we end up producing electricity or electrical energy. A turbine is a device with fan-like blades that turn when they are pushed, for example, by water or steam. So if you take a look up here, we've got 2 big turbines that are being lowered into a generator, or that are a part of a generator. Now, what role does a turbine play in this whole process of electricity? Is it, how often are turbines used? Well, the mechanical energy from the turbine can come from a very large variety of sources. For example, you could have water moving downstream turn a turbine. So that's going to be something like a dam where the water turns the turbine. You could have wind turning a turbine. That's going to be those windmills and wind turbines that you see in farm fields sometime. You can have tides turn turbines. So underwater, you have these turbines, these fan-like blades that move as the tide comes in and out. You can have steam from a coal fire. The steam is going to rise up, and if you concentrate it, you can turn a blade with steam. You can make the steam from a nuclear reactor and have the reaction heat up the water and create steam, which will then turn a turbine. You could also use the heat of the earth to create the steam that will turn the turbine.